A network solid is an atomic solid that has multi-directional covalent bonds. So the keywords there are multi-directional covalent bonds. So basically it just has a whole bunch of covalent bonds in 3 dimensions, and all of those extra bonds gives it special properties. And for this, really all you need to know is that it has those covalent bonds in multi-directions, and that some examples of each one. So here are 3 of the major examples. Ice is a network solid, graphite is in your pencils, and you can see it makes kind of hexagons, and those sheets of hexagons can break off onto your paper, and that's how you write. And then diamond, because of those bonds, it makes it the strongest thing on Earth. So the only thing you can cut a diamond with is another diamond. Here's just a few more examples. We talked about polymers when I did that newspaper demonstration. Poly just means many, and mer means unit. So it's any long chain of molecules. So you can see this molecule is a really long chain here for nylon, and PVC is another one. And the final example are proteins, so things like your hair and DNA. So let's talk about the shapes of molecules. The first thing you need to know is what we call the VSEPR theory. It actually looks like VSEPR, but scientists call it the VSEPR theory. So here's what it stands for, and you need to know what all those letters are. It's valence, shell, electron, pair, repulsion, which sounds really fancy, but it's actually not, because you already know all of those words. You should know by now that the valence shell is the outer shell of the atom, and it should make sense to you that electrons are going to repel each other because all electrons are negative. So this theory is going to allow you to predict the shapes of different molecules. And to say it in my own words, just so it's not so fancy with the science, basically this is showing how the repulsion between outer electrons is going to push the shape of the molecule so that those electron pairs are as far apart as they can possibly get. And when you're trying to figure out the shape, don't forget that you have to draw that dot diagram first. If you get lazy and stop drawing those diagrams, you're going to start to mess up on the shapes. So it's really important that you do what we did yesterday with those dot diagrams. So here's the first one. Anytime you have 2 things bonded to a central atom, so those 2 yellow spheres bonded to the middle red one, the farthest that those 2 yellow ones can get apart is straight across. So the idea with VSEPR theory is that there's an electron cloud here around this atom, and there's another electron cloud around this other yellow one. And those 2 electron clouds are repelling each other. So it's going to push those yellow atoms to be as far apart as they can possibly get. And if you only have 2, the farthest they can get is straight across from each other, and hopefully from geometry you know that that would be 180 degrees. I also want you to jot down, I'm going to add it to the PowerPoint, I wish I had done it earlier, but for a linear shape, if you only have 2 atoms, like if you just had 1 red and 1 yellow, the only shape it can ever be is linear. So for 2 atoms, the only shape you'll ever see is linear. If you have 3 and all you have is 2 atoms stuck to 1, then it's also going to be linear. If you have 3 things, notice that it makes a triangle, and it's a perfect equilateral triangle, so all the bond angles are 1/3 of a circle, which is 120 degrees. And we call it trigonal. The tri describes how many atoms are bonded to the central one, and planar means that they're in the same plane, and hopefully that word is familiar to you from biology. Plane means flat on the table. If you have 4 things, it's tempting to say it would make a square, but the bond angles for a square would be 90 degrees, and if you make it look like this, where it's like a pyramid with one sticking up, this is actually 109.5 degrees. So this is a much better arrangement for the atoms, because the yellow ones can get a little bit farther apart than they could if it was a square. And we call it tetrahedron. Tetra is a prefix for 4. You're probably more familiar with words like quad or quattro, but tetra also means 4, and you might have seen it if you ever play the game Tetris. All the game pieces in the Tetris game, each piece only has 4 squares. So because of that, they named it Tetris. So just remember that 4 is Tetris. And there's several different arrangements of this one. So if you have 4 atoms, you're going to call it a tetrahedron. If one of these has an electron cloud, so for example, if you draw at NH3, you'll see that the N is single bonded to 3 of the hydrogens, but there's 2 extra electrons on that nitrogen, and I tried to put it up here for you. These are these 2 electrons up here. Those electrons are still going to push on all of these atoms because they don't like the atoms, because these have electrons on the outside. So these 2 electrons are repelling the electrons on each of the green atoms, and so it pushes them into a pyramid. So it's trigonal because you have 3 atoms stuck to the middle one, but this time it's a pyramid because these 2 electrons here are pushing down the other 3 atoms. So the only difference between trigonal planar and trigonal pyramid is that the pyramid has those 2 dots on it, and the planar one doesn't have the 2 dots on the central atom. And the last one is if it's bent. So if you picture this molecule, the tetrahedron up here, if 2 of these yellow spheres were electron clouds, like when you draw out water, then it's going to end up looking bent, just like this. And keep in mind that the electron clouds actually take up more space than just an atom over here. So if you had the trigonal planar, it would be 120 degrees. If one of those was an electron cloud, it's going to push those little purple ones together just a little bit more, so it'll be slightly less than 120. So keep in mind that the clouds actually take up more space than just an atom. So when you try to figure out the shape, the point of this slide is that you need to draw the pictures. Because if you have something that's 3 atoms, like H2O versus CO2, H2O is bent and CO2 is linear. So you can't tell just by looking at the number of atoms what kind of shape it's going to be. You actually need to draw out the diagrams with your dots to figure out how the electrons are going to affect the shape. Same thing down here, if you sketch out PH3 and BH3, you would think they're the same shape because they look so similar, but the phosphorus has an extra electron cloud on it, which makes it pyramid, and the boron does not, which makes it planar. So it's really important that you draw out these shapes. So tonight, if you have the worksheet packet, worksheet 4 will allow you to practice drawing these pictures and figuring out the shape. And we're going to go over the answers to that tomorrow in class. And that's it for today.